G'day. The other day I was making up a couple of little clamp blocks, nothing terribly exciting about them. They're just an L-shaped piece of stuff. But I wanted to put chamfers on the corner. And previously to doing that I would have had to set up each corner individually, and there were 8 corners to do. And I thought, no, I'm not bothering to do that. So instead I've made up some, I guess you'd call them V parallels. And I've never seen any of these around the place, so it could be a new bit of tooling. Who knows? But yeah, I'll show you how I made those, and then I'll show you the sorts of things they can do. This is where this actually started. These are a hold down clamp for the XY table I did, because when I bolted down to the rotary table I found I was a little bit short of clamp space. I thought I'll make up some special clamps for it, and that'll be that. What I'd like to do is put a bit of a chamfer on there, but I've got 2 of these and each one's got 4 corners, and so that's a lot of stuffing around setting up. So I was trying to work out a way to be able to position these for chamfering easily, and I think I've come up with something. I'm starting off with a couple of bits of plate. This is 5mm thick because there are things that are probably quarter inch thick, 6 point something or other millimeters, which I'll probably want to chamfer. It's 36mm high, which is the height of my vice jaws, which is very important. It's 130 long. My vice is 100, and that just gives me a little bit of space here for a hole. What I'm going to do now is fasten these 2 together, like so, and with the magic of television, scribe some lines on there. This is stainless. I wanted something a bit harder than mild steel, so I'm going to cut these out with an angle grinder and then trim them up with a milling cutter. I've got the 2 bolted together because I want these notches to be in the same position relative to the holes. These holes are sort of a tooling hole and sort of a fixturing hole. I've hacked out most of the stuff I'm going to be removing with the angle grinder, and that's just because trying to cut stainless like that can be a bit of a pain. There's a lot of material to remove, everything gets hot, you've got to keep it sluiced down and all that sort of thing, so easier just to cut it out. Marking out was pretty straightforward. I just got my little square thingy and scribed that. That's plenty accurate for what we're doing, because what we're trying to do is just make sure that we get a 90-degree angle, which the cutter will get it, and we want that to be, it's 45 degrees to the horizontal, and that'll do that. There's my finished machined part or parts. Because I've got them bolted together like that and I've clamped them tight in the vise, it means that with respect to these holes, these 2 V's, 3 V's, are in the same spot in a relative way. What that means is that I can get a bit of rod. This is some 5mm rod and those are 5mm holes, and I can put those through like that, and that'll keep those in relative position. Now this isn't designed to sit like this. This is designed to go into a vise, and so I can put that into a vise, and if I want to chamfer that corner, I can have that sitting like so and do that. Now I'm going to do these corners here, so I'll probably only use one of these. But same thing applies. What else can this wonder piece of tooling be used for? Well, if you have the joining rod, which is probably really more a stop rod than anything, and that's just preventing that going that way, you can use this as a V block. Now you can either put a square bit of stock in there and knock the corners off, or you can do as I've done here and put a flat on a piece of ground, which may come in handy, or if you need to drill a hole or something like that, you can do that. I made up a set with a 30-60 notch in it, in case I wanted to put a 30-degree angle on something. But what I realised is if I had a bit of a round and I put a flat on either side, which is pretty straightforward and easy to do, but I can then put that in there like that, and I can then run across the top of that and turn that over and all that sort of thing, and I can make myself some hex bar stock. So if you're ever caught short of a little bit of hex, then there's a solution for that. Prior to doing this, what I would have had to do to get this result would be put a bit of stuff in the collet chuck and machine it, and you can probably only get a little bit out of that. Here I can get up to the full length of the vise, so 100 millimeters. Here I am all set up to try and make some hex bar. So I've put flats either side here. I've got it sitting against the face there. I've got my rod in there, and then I've seated that against that surface so that it's pulled up against the rod and it's pulled onto that face. Pause here for a quick confession. This is actually the second time I'm doing this. The first time I did it, I used a piece of material and I thought, right, I'll get a hex which is fully within that bit of material. But it didn't come out right. And what I worked out was that, if you can imagine, that's the surface that the flat is sitting on, and that's the one at 90 degrees. When I first started out, I was on the round of the bar, but once I'd trimmed that off, I was then sitting on the corner, and so everything moved. What I'm doing here is I'm making a bit of hex where the virtual corners are outside the bar, and so what that should mean is that when that's sitting flat on the fixture, this bit is always going to be on one of these corners which isn't properly formed, and so that should give me a much better result. And there's the result of my self-manufactured bit of hex bar, and as you can see, 2112, 2116, 2114, so 1217, 0.05. That's not too bad at all. I'm not quite sure what I'll use a piece of 21.1 hex bar stock for, but I'm sure there'll be a reason to use it for something. Anyway, thanks for watching, and we'll see you for the next one.